Hello everyone, it's me Sir Chris, and in this video I'm going to discuss some basic concepts about compound interest. Particularly, we're going to compare simple interest with compound interest, solve some problems using compound amount and the present value formula, and solve some problems where the instances where n is not a whole number. Before we dive into the actual content of this video, let me first quote Albert Einstein regarding his words on compound interest. Albert Einstein said that compound interest is one of man's greatest inventions. It is considered as the eighth wonder of the world. Those who understands it, earns it, and those who do not, pays it. And as we go along with the content of this video, hopefully you will gain a grasp on the mathematics behind it and understand the power of compound interest. Compound interest can be defined as an interest computed more than once over a period of time. It is said that more than once because of the concept that interest bears interest. Simple interest is calculated on the principal or on the original amount of the loan or investment. On the other hand, compound interest is calculated on the original amount plus the accumulated interest on the previous periods, thus regarded as interest on interest. In this illustration, I'm going to show you how simple interest and compound interest accumulates over some period of time. For instance, we're given the original amount equivalent to 10,000 pesos with a rate of 10% per annum and within a period of 2 years. In simple interest, at t equals 0, the original amount is 10,000. And then after 1 year, this 10,000 will gain 10% of 10,000, which is equivalent to 1,000. Based on the formula, simple interest is equal to PRT, where the principal amount is 10,000, the rate of 10% over a period of 1 year. On the second year, it will again gain another 1,000 pesos based on this calculation. So after 2 years, the accumulated amount is equal to the principal plus interest, which is equivalent to 10,000 plus the interest on the first year is 1,000 and the interest on the second year, which is also 1,000, so the final amount is 12,000. So every period of calculation of interest, it is always based on the original amount. On the other hand, for compound interest, on the first year, it will also gain 1,000 pesos. Again, based on this calculation, interest is equal to PRT. So again, that's 10,000 times 0.1 for a period of 1 year. So this is equivalent to 1,000. On the next year comes the difference between simple interest and compound interest. It is no longer based on the original amount, but on the original amount plus the accumulated interest on the previous period. Therefore, for the interest on the second year, P will become 10,000 plus 1,000. So equivalent to 11,000. So computing for the interest on the second year, is equal to, again, formula of simple interest, PRT, equal to P, which is 11,000, times the interest rate 10% and another period of 1 year. So this is equivalent to 1,100. Therefore, the final amount for compound interest for the period of 2 years is equal to P plus I is equal to 10,000 plus the interest on the first year is 1,000 plus interest on the second year is 1,100. So this is equivalent to 12,100. So over a period of 2 years, simple interest, its final amount is 12,000. For compound interest is 12,100. So both of them started on the same original amount, same interest rate, same period of time, but compound interest gained an excess of 100 pesos simply because on the second period, its previous interest gained another 10% of this interest, which is equivalent to 100. The difference between compound interest and simple interest becomes more evident as we increase the number of years or increase the number of periods being considered in the calculation. As seen on this example, for an initial amount of 100,000 pesos or a rate of 10%, under simple interest, after a period of 10 years, you can see that it doubled its original amount to 200,000 pesos. But under the compound interest, with the same initial amount, same interest rate, and the same 10-year period, the final amount is more than 259,000. And aside from increasing the number of years, we can also increase the number of compounding periods within a year, such as compounded semi-annually, compounded quarterly, and compounded monthly. So the more compounding periods would give more compound interest, as you can see on the last periods of this table. And on this figure, you can see the behavior of simple interest and compound interest graphically. So as you can see, simple interest increases constantly over each period. So we can say that the accumulation of simple interest is linear as compared to the accumulation of the compound interest, which we can consider as exponential. So from the first illustration, I have shown you the computation of compound interest using the simple interest formula. So that's equivalent to a manual calculation of compound interest. And also, we can compute compound interest using what we call the compound amount formula. So the compound amount formula is given by F is equal to P quantity 1 plus I raised to N, where F is the final amount or the future value, P is the original amount or the principal amount. I is the interest per compounding period, where I is equal to J over M. In other references, it is equal to R over M, where R or J is equal to the nominal rate or the interest within 1 year over M, which is the number of compounding periods per year. And the exponent N is equivalent to the total number of compounding periods over the number of years being considered, where N is denoted by N is equal to M times T. Before we can compute the compound amount or compound interest, first we need to convert the nominal rate to its equivalent interest rate per compounding period, as seen in this table. So for instance, a nominal rate of 12% compounded annually. So therefore, the number of compounding period is 1. So the interest compounding period is equal to J over M or R over M, which is 12% over 1, which is equivalent to 12%. And for semi-annually, the number of compounding periods or M is equal to 2. Therefore, 12% divided by 2 is equivalent to 6%. For instance, in this example, find the compound interest due after 5 years if 10,000 pesos is invested 6% semi-annually. So we are given an original amount of 10,000 pesos with a nominal rate of 6% compounded semi-annually. What is the compound interest due after 5 years? First, we're going to determine the value of I, or the interest per compounding period. So that's J over M or R over M in other references. So J is 6%, M is 2, so this is equal to 3%. Then determine the value of N. N is equal to M times T, which is equal to 2 times 5 equal to 10. We can compute the compound interest first by determining the value of the compound amount. So F is equal to P times 1 plus I raised to N, where P is equal to 10,000 and 1 plus I is 0.03 and the value of N is equal to 10. And the final amount is 13,439.16. The compound interest is equal to the final amount minus the original amount. So the final amount is 13,439.16 minus the original amount of 10,000. So the compound interest over a period of 5 years is 3,439.16. So before you can compute for the final amount or compound amount, first you need to identify the original amount, the nominal rate, the number of compounding periods per year, the number of years given, and then identify the value of I, which is equivalent to J over M, and the value of N is equal to M times T. There are some problems under compound interest in which your objective is to find the original amount of an investment or a loan. So for instance, you are interested to know how much should be invested at present in order to gain a final amount of 1 million pesos over a period of 10 years with an interest rate of 10% compounded quarterly. So we're looking for the amount to be invested at present. So this is a case of what we call the present value. So present value can be determined using the compound amount formula. So this is the final amount, or what we call the future value, and P, the original amount, can be designated as the present value. So in order to determine the formula for P, so we divide both sides by the quantity 1 plus I raised to n. Therefore, P is equal to F over 1 plus I raised to n. This is also equivalent to F times 1 plus I raised to negative n, based on the laws of exponent, which is given by a raised to negative n is equal to 1 over a raised to n, and similarly 1 over a raised to n is equal to a raised to negative n. And going back to this example, we're looking for the present value, or we are determining the amount should be invested at present in order to gain 1 million pesos for a period of 10 years with an interest rate of 10% compounded quarterly. So the value of I is equal to J over M equal to 10% divided by 4 equal to 2.5%, or this is 0.025 in decimal form. And the value of n is equal to m times t equal to 2 times 10 years equal to 20 periods. Therefore, the present value using this formula is equal to, the final amount is 1 million pesos times 1 plus 0.025 raised to 20. And that's equal to 610,270.94. This present value, again, it means that in order to gain 1 million pesos after 10 years with this interest rate and number of compounding periods per year, you need to invest 610,270.94 at present. There are also problems under compound interest, finding the future value and the present value, where n, the number of compounding periods, the total number of compounding periods, is is not equal to a whole number, or there is an excess number of months or number of days in the time given. So for instance, in this example, find the compound amount at the end of 3 years and 5 months if 20,000 is invested at 8% compounded semi-annually. So the given of the problem, so we're looking for the final amount given an original amount of 20,000 for a period of 3 years and 5 months. The interest rate is 8% compounded semi-annually. So the interest per compounding period is 8% divided by 2, so that's equivalent to 4%. The value of n is equal to, so that's m times t, so that's 3 years and 5 months. So for 3 years, the value of n is 2, the number of compounding periods per year, times the number of years, 3 years. So n is equal to 6. And since the interest compounding period is semi-annually, the remaining 5 months will no longer be equal to 1 period. So it is 1 month less than the required number of months of semi-annually. So how are we going to find the final amount with this given situation? We can determine the final amount in 2 steps using this timeline. So we can determine the final amount after 3 years and 5 months using this timeline. First, by accumulating your original amount of 20,000 for a period of n is equal to 6. We can temporarily solve for the final amount up to this period. And then, determine the true final amount for the remaining 5 months by using simple interest. So for step 1, find the temporary final amount for n is equal to 6. So this is equal to p 1 plus I raised to n. Original amount is equal to 20,000 and interest per compounding period is 4% raised to 6 periods. 25,306.38 as our temporary final amount after 6 periods. The next step is to determine the interest gained for the remaining 5 years using simple interest, using F1 or 25,306.38 as original amount. So P will be equal to 25,306.38 times the interest rate, which is equivalent to the value of J, which is 8%, over a period of 5 months. So that's 5 over 12. This is equivalent to This is equivalent to 843.55. So the interest earned for the remaining 5 months is 843.55. Therefore, the true final amount, F2, is equal to the accumulated amount after 6 periods, which is F1, plus the interest gain for the remaining 5 months, is equal to, that's 25,306.38 plus 843.55 equal to 26,149.93. So this will be the final amount of 20,000 after 3 years and 5 months with 8% compounded semi-annually. We can also combine this two-step process into a single formula. F2, the final amount, is equal to P times 1 plus I raised to N times 1 plus J times T. This part determines F1, and the combination of these two determines the value of F2. So this is equal to 20,000 times 1 plus 0.04 raised to 6 times 1 plus 0.08 times 5 over 12. This is also equal to 26,149.93. There are also cases in finding the present value and n is not a whole number. So this is an example of that. So find the amount to be invested today in order to accumulate 300,000 pesos after 5 years and 4 months if the money will grow at 10% compounded quarterly. So our future value is 300,000. And we are looking for the present value given a time of 5 years and 4 months with a nominal rate of 10% compounded quarterly. For this case, the value of I is 10% divided by 4. That's equivalent to 2.5% or 0.025 in decimal. And the value of n is equal to, so we're going to determine how many compounding periods are there or how many quarters are there in 5 years and 4 months. So for the case of 5 years, so we have 20 periods. And in the remaining 4 months, we can still form one period. So 1 quarter is equivalent to 3 months. So we can add another quarter here. So that's 21 quarters plus 1 month. So 21 quarters and 1 month is equivalent to 5 years and 4 months. So the next step is to add additional months in order to make this excess month into one more quarter or one more period. So for this case, we're going to add 2 more months. Therefore, this is equivalent to 1 more quarter, and the value of n is equal to 22. So we're going to find the present value using n is equal to 22. So this part of the timeline is equivalent to 21 periods in 1 month, but we're going to find the present value of 300,000 for 22 periods. Therefore, the present value we're going to calculate will be placed here on the timeline, which is 2 months past of the original present value we are trying to determine. So first, we're going to compute the temporary present value on this point, and then we're going to accumulate this P1 towards this part of the timeline, P2, in which P2 is the true present value using simple interest for a period of 2 months with the rate of 10%. So again, this is a 2-step process. So for our step 1, we're going to compute P1 using n is equal to 22. So that's f times 1 plus I raised to negative n. So the final amount is 300,000 times 1 plus 0.025 raised to negative 22. Therefore, our temporary present value is 174,259.40. And then for step 2, so the interest gained on this period is equal to, so we're going to use 174,259.40 as the principal amount times the interest rate per year is 10% over a period of 2 months, 2 over 12, equal to 2,904.32. Therefore, our true present value is equal to P1 plus the interest gained for the remaining 2 months. So that's 174,259.40 plus 2,904.32. And the true present value is equal to 174,259.40 77,163.72. And again, we can combine that two-step process into a single formula using P2 is equal to F times 1 plus I raised to negative N times 1 plus J times T. So, for this case, the final amount is 300,000 times 1 plus 0.025 raised to negative 22 times 1 plus 0.1 times the added months 2 over 12. Again, this part computes the temporary present value where we added one more period to n. And this factor computes for the true present value of, and this is also equal to 177,163.72. And the following are additional examples for solving the future value and the present value for n is not a whole number in a fast-forward motion. that's it. Thank you for watching.